Chapter 7 discusses continuous probability distributions. And in this chapter, we're just going to include in our course 7.1, 7.2, and 7.3 learning objectives. The first learning objective is the uniform distribution. This is the simplest distribution for a continuous random variable. A continuous random variable can take infinite values in an interval. For example, between 10 and 15. You can take values like 10.1, 10.12, 10.123, 10.241, etc. So it is not discrete. Discrete would be 10, 11, 12, 13 only. But in this case, it's continuous, as it is very often the case for popular variables such as weights, heights, GPAs, etc. The distribution is rectangular in shape and is defined by minimum and maximum values. The minimum is A and the maximum is B. A and B. Could be, let's say, 20 and 12. 20 minus 12, it'll be 8. So I had something written before. So, for example, it's not a perfect line, obviously. I said between 20 and 12. So the difference between the two would be 8. And what will be the height here of this rectangle? Well, the rectangle in a probability distribution includes all possible values. So this area is always has to be equal to 1 by definition. And so if we know that 8 is the horizontal and the rectangle area is equal to 1, so this is always equal the base times the height, and this 1 must be equal to 8 times the height, but the height has to be 1 over 8 if we want it to make it equal to 1. Okay, so the 8 and the 8 cancel each other. So the height of this rectangle on the vertical axis has to be 1 over 8, which is the inverse of the B minus A on the horizontal. So that's why you see here 1 over B minus A. Knowing the minimum and maximum values of a uniform distribution, we can define the probability function and calculate the mean, the variance, and the standard deviation, which is just the square root of the variance. Probability is defined as 1 over B minus A, as long as x is between A and B, but it is 0 elsewhere. So in other words, it's only defined for values between A and B. The average is just the addition of the two values, maximum and minimum, divided by 2. And the variance is B minus A squared divided by 12. And the square root of that will be the standard deviation. For example, Southwest Arizona State University provides bus service to the students. On weekdays, a bus arrives at the North Main Street and College Drive stop every 30 minutes between 6 a.m. and 11 p.m. Students arrive at the bus stop at random times. The time that a student waits is uniformly distributed from 0 to 30 minutes. Draw a graph, show that the area is 1. How long will a student typically wait? What is the probability that a student will wait more than 25 minutes? What is the probability that a student will wait between 10 and 20 minutes? Well, in the rectangle, we have the horizontal axis of base defined between 0 and 30 minutes. So what will be the height? Well, the height has to be the inverse of that, and that would be 1 over 30, the inverse of the distance between maximum and minimum. And that is equal to 0.0333. So what would be the area? 1 over 30 minus 0 times 30, or the height times the base. And that is equal to 1. How long will a student typically wait? Well, that is the average. The average is defined as equal to a plus b divided by 2. So 0 plus 30 divided by 2 is equal to 15. What is the standard deviation? Well, it's the square root of the variance. 30 minus 0 squared divided by 12, that is 75. Then the square root of that is 8.66. That is the standard deviation. What is the probability that a student will wait more than 25 minutes? Well, more than 25 minutes is 25 or higher. The highest possible value is 30. So it's the area between 25 and 30 with the same height here. So it'll be 5 on the base and 0.0333 on the height. If you multiply those two values, you get 0.1667 or 16.67% chance. What is the probability that a student will wait between 10 and 20 minutes? Well, just concentrate on the area between 10 and 20, and the height will be the same. 20 minus 10 in the base is equal to 10, and the height is always 0.0333. Remember, that's the inverse of 30. And so it'll be 1 over 30 times 10 equals 0.3333. So the probability is 33.33%. And that's the end of section 1.